All right. In this video, I still have the hiccups. Thank you for asking. And we are going to look at the surface area of prisms and cylinders. Surface area. Great. Let's talk about surface area real quick. When it comes to surface area, that means, like, if I were going to wrap this up, how much wrapping paper would I need to wrap it, right? So I'm just, without any overlaps, just exactly how much would we be using, right? So when it comes to surface area, the surface area would mean I need to know the area of this, all the sides, right? So this side, this side, that side, the top, and all four of the sides here. Did I say too many sides? Yes. There's 6 sides to a rectangular prism, and that, okay. But what we need to do is we need to look at this as base. We have 2 bases that are the exact same, right? So I could find the area of one base and multiply it by 2, and then I'd have those sides, right? Then what we're going to look at is what's called lateral area. Lateral, meaning in football, if you throw a lateral, it's either to the side or back. Sides is all it really means. The lateral area is the side area. What are the area of the sides, right? So if you take the base off, this base off, what's the area of the sides? One way of looking at it, and I have this, so let's take a look. This is a triangular prism. My son made this triangular prism, and he looked at it and goes, triangle. So I have to give it back to him, and he's actually a little upset that I took his toy away. Yeah, I'm so poor my kid plays with cardboard. Anyways, so let's take a look. We have a triangular prism. You can imagine we took the top and the bottom off, right? We took the bases off, and now we have just the 3 sides left over. But what happens whenever we take the top and the bottom off? What I can do is I can unfold it, right? And now I could look at it like one big rectangle or 3 individual rectangles, right? So when it comes to prisms, right, the surface area of a prism, we got to think about the surface area, the top and the bottom, and then the lateral area of the sides, right? The area of the sides is called the lateral area. So let's take some notes on this stuff real quick, and then we can start looking at some formulas, right? All right, so surface area is, so surface area, it's made up of 2 things, right? We have 2 times the area of the base. I'm going to put that in parentheses, plus lateral area. And I put a period at the end of this for, this is such a weird deal. Just know, surface area, 2 times the area of the base plus the lateral area. Okay, so let's take a look. Let's take a look at this. What we need to understand is something called a net. A net. It is a 2-dimensional drawing of a solid. And you want to think about that. When I opened up that triangular prism, that piece of cardboard, that is technically called a net. So let's take a look. A net is going to help us with the surface area and the lateral area. And here's what I mean by that. Let's start with a cylinder here. This is a horribly drawn cylinder, and that is okay. Here I have a cylinder. Oh, it should be dashes because you can't see that part. Oh well. Let's say this has a radius of 3 millimeters. We're really doing a great job of making this up. And let's say the height is 9 millimeters. Okay, cool. All right, so if I'm going to draw a net for a cylinder, let's take a look at what happens. We can use this roll of paper towel, right? That's a good cylinder, right? It's got a top, 2 bases, right? So if I take the bottom circle off and the top circle off, then I have to undo this. And if I think about it, like when I undo this, I end up with a rectangle, right? I end up with a rectangle. So when I draw the net for a cylinder, when I draw a net for this cylinder, I have a circle at the top, I have a circle at the bottom, and then I have a rectangle that goes with it. So now we can label all of our parts here. We know that this radius, that radius equals 3 millimeters. We know the height is 9 millimeters. Now we need to look at this area here, right? This part in the middle would be my lateral area. So this is the lateral area, okay? So let's find the surface area of this cylinder. To find the surface area of this cylinder, we need to first get rid of your hiccups. And you can do that by holding your breath. Okay, so we need 2 area of the bases. So my circles, the area of the base. Right, the area of the base here is pi r squared, and my radius is 3. So I'm going to have 2 times pi 3 squared. And then the lateral area, which is a rectangle. So I need length times width. So plus length times width. Length, we're missing our length, times we got the width. I need the length. How am I going to figure out the length? Okay. Hopefully this part will help. So, looking at this thing here, right? Remember, here I have just a nice little circle. And the length of that rectangle, you can imagine if I open this up, here, right, this would be the rectangle part. So the length of the rectangle would just be 1 trip around the circle on the top. And what's 1 trip around the circle on the top called? Circumference. Way to go. I'm really proud of you. So for a cylinder, the lateral area, right, I need to know the circumference of the circle, which is 2 pi r. And our radius here is 3. So the length of this rectangle is 2 pi times 3. So I get 2 pi times 3. That's the length times the width, then is going to be 9. Whew! So my total surface area is the 2 times the area of the base plus length times width of the rectangle in between. And the length and the width of the rectangle in between, this whole thing right in the middle is called the lateral area. This is my lateral area. I can plug all this stuff in the calculator. Let's do that. Let's round it to the nearest 3 decimal places. So 2 times 3.14 times 3 squared is 56.52 plus 2 times 3.14 times 3 times my height of 9 gives me 169.56. Add that together to get my whole surface area. I get my surface area is 226.08 hiccups. No, that's 226.08 millimeters squared. All right. Woo. Okay. So my suggestion when it comes to finding surface area, and oh my gosh, that is the cutest little baby I've ever seen in my life. I hope she can cure hiccups. Sorry, my daughter just came in and she's so cute. In fact, come here, bring her here. You want to see what was so distracting? This little cute baby monster here. Yay! Love you so much. Yeah, we're doing surface area. Maybe one day when you're in high school and you revisit all these videos, you're going to go, that was me, Dad. And I'm going to go, yeah, that was you. Yeah, party rock. Don't look at me like I'm crazy. Love you.
I love you.
Cute kid. I'm so lucky. All right. Let's take a look at some examples here. We already did one for a cylinder, so I'm going to skip that. But I'm not going to skip this example here for a trapezoidal prism. Now, it only works if you have an isosceles trapezoid. All the ones in the examples are isosceles trapezoids, so this is going to work. They gave us a bunch of dimensions. Let's start by creating the net, okay? So I'm going to create the net with these. I'm going to draw that trapezoid here. And I'm going to label everything I can about it. So I know that's 15 meters. Here, this is 11.4 meters. I probably shouldn't have done that one, and that's okay. The base here is 9 meters. And the altitude of this guy is 11 meters. Okay. So when I go through, now it has underneath, so it has 1, 2, 3, 4 sides, right? It has four sides. So I'm going to draw those sides, those rectangles here, 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 and then that big one on top is going to go there. And then my other trapezoid is here. Now, I need to figure out how this is going to work, right? So remember surface area. So surface area is 2 times my bases plus my lateral area. The lateral area here is these 4 rectangles. And what's really nice about these 4 rectangles is they all have the same height. So we could just add up these 4 lengths, and then we'll have 1 length and 1 width. I didn't mean to say height. I meant width, I suppose. Okay. So remember, the area of the trapezoid, is base 1 plus base 2 times the altitude divided by 2. So here we go. Our surface area is, for this one, base 1, we have 15. Oh, excuse me, I need 2 of these. Hold on. Let's see. Let's go 2 times. Okay, base 1 plus base 2. Oh, I just write it out, Stevens. Sorry. Erase. Try again. We'll try again. We have 2 times, now base 1 we have 15 plus base 2 we have 9 times the altitude here is 11. All of that divided by 2, right? So base 1 plus base 2 times the altitude is the area. Oh, divided by 2 is the area, excuse me. And then We're going to multiply it by 2 because we need 2 of these. Okay, we good on that? Good. Plus, now I need the lateral area. The lateral area, that's this in the middle here. So looking at this, I know that the width of our lateral area, our width is going to be 10 meters. So I have a 10 here. So length times width, 10 times, and now I need to add up to all 4 of these, okay? So this one, this here, this length is the same as this length, right? Those are the same lengths, and that is 11.4. And then this length is 9. This length here is the same as that one, so I get 11.4. And this length would be the top length here, so that would be 15. And when I add those up, I get 15 plus 9 plus 11.4 plus 0.4 plus, and that's it. 1, 2, 3, 4. Okay. All right, so when I add all those up, I get 46.8. Wow, excuse me. So length of 46.8, width of 10. Okay, so now I can do all my calculating here. In my calculator, I'm going to start with this guy here. So 15 plus 9 times 11. So 15 plus 9 times 11. I'm just going to give me a number here. Now, I'm going to divide it by 2 and then multiply it by 2. That just seems silly. That just seems silly. So I get 114 plus 46.8 times 10. I'm going to be smart and just move my decimal over, and I get 468. 114 plus 468 gives us a grand total of 582 meters squared. So the surface area for this trapezoidal prism, the surface area is 582. The lateral area, as we saw, was 468 meters squared. So your homework's going to ask what's the lateral area and what's the surface area. Now remember, when it comes to surface area, 2 times the area of the bases plus that lateral area, okay?